Hello, friends. Mr. Ryan back again. We've already talked about the makeup of the cell membrane. We've talked about passive transport, how things get into the cell without using energy. We talked about diffusion, facilitated diffusion, and osmosis. We are now ready to talk about osmotic pressure. For organisms to survive, they must have a way to balance the intake and loss of water. The net movement of water out or into a cell exerts a force known as osmotic pressure. Because the cell is filled with salts, sugar, proteins, and other molecules, it is almost always hypertonic to fresh water. In other words, there's going to be less water inside the cell than there is outside the cell. Why? You have more solutes inside the cell taking up the space. So when you have more water outside the cell than you do inside the cell, the water will go inside the cell. Okay? So as a result, water tends to move quickly into the cell surrounded by fresh water, causing it to swell. Eventually the cell will burst. If you look over here in the blue section, so we have our cell, our blood cell, with all the sugars and proteins and sugars. And we have the water, which doesn't have all that stuff. So where's the most water? Well, of course, the most water is on the outside, and then there is on the inside. So when we have that situation, more water on the outside, well, it wants to go in the inside because that's where the less water is. This is a blood cell. This is a plant cell. Same thing. In plants, the movement of water in the cell causes the central vacuole to swell. Remember, the vacuole stores water and other things. It to swell, pushing cell contents out against the cell wall. Since most cells in large organisms don't come in contact with fresh water, they're not in danger of bursting. Instead, cells are bathed in fluids such as blood that are isotonic. So that means there's going to be the same amount of water on the outside as there is on the inside, okay? They are isotonic, okay? So the cells are bathed in fluids such as blood that are isotonic and have concentration of dissolved materials roughly equal to those in the cell. So the dissolved materials and water on the outside of the cell are equal to the dissolved materials and water on the inside of the cell. Therefore, we don't have a lot of water going from a high concentration to low concentration because everything is equal. It's isotonic. So in other words, the shape of the cell does not change. So in our blood cell and our animal and our plant cell, going to be okay. There's not going to be any change. It's not going to shrink. It's not going to get larger. So cells placed in an isotonic solution neither gain nor lose water. In a hypertonic solution, water rushes out of the cell, causing animal cells to shrink and place cell vacuoles. So if the water is going to rush out of the cell, that means there's got to be more water inside the cell. So the hypertonic solution has a lot more solvents in it and a lot more things floating around in its water. So there's more water on the inside of the cell than there's on the outside of the cell. And what happens? The water wants to go from a high concentration to low, so therefore the water will leave the cell and it'll shrink. Some cells, such as the eggs laid by fish and frogs, they're going to come in contact with fresh water. These types of cells tend to lack water channels. As a result, water moves into them so slowly that osmotic pressure does not become a problem. Other cells, including those of plants and bacteria that come into contact with fresh water, are surrounded by tough cell walls that prevent the cells from expanding even under tremendous osmotic pressure. Notice how the plant cell holds its shape in a hypotonic solution, while the animal blood cell does not. So in the hypotonic solution, the blood cells go swell up. However, because of the cell wall, the plant cell does not. So however, the increased osmotic pressure makes such cells extremely vulnerable to injuries in their cell. So even though they're not swelling up like the blood cell, they're still going to get injured. Okay? Friends, That's the end of our short lesson here today. As usual, have fun and enjoy learning.